Truth table for the conditional. A conditional is a logical statement of the form if P then Q. The conditional statement in logic is a promise or contract. Consider this example. A parent says to a child, "If you eat your vegetables, then you will get dessert." Well, the only time that this conditional statement, P implies Q, or if P then Q, is false, is when the contract or promise is broken. So if we look at our truth table that we have here, we have the four cases. We have true then true, true then false, false then true, false then false. The only time when the third column of this truth table, P implies Q, is false is when the promise is broken, when the condition is true but the conclusion is false. So the case of true then false, that conditional statement is false. In all other cases, it is true. So thinking back about a parent and a child, if you eat your vegetables, then you'll get dessert. In this case, if the child doesn't eat their vegetables, then at that point, it's actually up to the parent, right? They can be kind and go ahead and give dessert. So we can have false, and then who cares what Q is, true or false. Then the statement is still true because the parent has kept their part of the contract. The only thing that matters, the only time that it's false, is when the child eats their vegetables, the parent doesn't give them dessert. That is the statement true then false, and in that case the conditional is false. So again, there's our truth table for the conditional. P implies Q on the right. Example, truth tables number 6. Construct the truth table for the negation of P implies the negation of Q. Or, read another way, not P, or if not P, then not Q. So we have this table already drawn out for us. We have 5 rows and 5 columns. The first 2 column headers are P and Q, and we have our 4 statements below this, or 4 possibilities below this. True then true, true then false, false and true, false and false. So to complete these headers, they need to build up to the completed statement, not P implies not Q. In order to build to this completed statement, we need the statements not P and not Q. So our column headers are P, Q, not P, then not Q, then if not P, then not Q as our last column header. In order to determine the third column, not P, we look at the column that is labeled P. And we take the negation, so we change all of our trues to false and all of our falses to true. That makes this column, this third column, equal to false, false, true, true. For the fourth column, we need to find the Q column and find the negation of that column. So we're looking at our second column and reversing these, okay, from true to false, false to true. So that makes our fourth column false, true, false, true. And finally, we are, for our last column, going to look at not P and the not Q column. So that's our third and our fourth columns, and we're applying the rule of the conditional. So this means that if the first part, the premise is what we call that, if the premise is false, then the entire conditional is true. And the only time that this is broken, this contract is broken, is when the premise is true. I'm pointing at this true in the not P column. When the not P is true, but the not Q is false. So applying the rules from that previous slide, we have this final column as true, true, false, true. Example, truth tables number 7. Create a truth table to determine if the following compound statements are logically equivalent. So we have 2 statements that follow. We have P implies Q and not Q implies not P. We're going to find the value for each of those and determine if they're logically equivalent. We'll see if they have the same values in all cases. So I'm going to go ahead and fill in the headers of this to be not Q and then not P. P implies Q and not Q implies not P, because these build up to our two completed statements in the last two columns. Now, using the two completed columns of P and Q, which are true, 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 false, false, true, false, false, we can now move on to our third column. The negation of Q, because of the column that is labeled Q, we will take the negation. So the third column is false, true, false, true. Similarly, for the fourth column, not P, we'll look at the column labeled P and negate those values. So that means the fourth column is false, false, true, true. For our fifth column, we will look at P and Q, those two columns, and apply the rule of the conditional. So when the premise is true and the conclusion is false, then it will be false, otherwise it will be true. So if true, then true is true. It's true, then false, that would be false. False, then true is true. False, then false is true as well. Now for our final column, the sixth column, we have not P implies not Q. For this, we will look at the two columns labeled not Q and not P respectively, and apply the rule of the conditional. So the premise being not Q, we look at these values and we have this statement. False, if false, then false, that would be true. If true, then false, that would be false. The only place it is false. If false, then true is true. And if true, then true is also true. So are these statements logically equivalent? Well, if we look at those last two columns, I'm boxing those in, we have the exact same truth values for all cases. Therefore, these two statements are logically equivalent.